Well, students, we have covered so far the bounds for the option prices, and also we have studied put call parity relation between put and call prices. Now we will pass on to some more properties of the option prices and what is called the time value of the option prices. As a first step, let us prove how the option price depends on the strike price. This also establishes an important property of the option price, that is the Lipschitz continuity condition of the option prices. So the theorem goes like this: if the underlying stock does not pay dividend, you can also establish these inequalities for dividend paying stocks, but let's not go into that routine work. And further, the market does not allow arbitrage. This is an important assumption which we always make. Then suppose you have two options, say K1 strike and K2 strike, both have the same expiration. Then as far as the call option is concerned, the difference between the price of the call option with K1 strike and the price of the call option with K2 strike, the difference satisfies this condition where K1 is less than or equal to K2. So the lower bound shows that the option price in the case of call option is a non-increasing function, whereas in the case of put option, it is a non-decreasing function, you can see from the second line. And similarly, if you see the upper bound, you can see that they satisfy the Lipschitz condition. What is Lipschitz condition? If you recall, if a function f is defined on an interval, say b to r, then you say that it is Lipschitz if for any xy in the interval ab, you have f of x minus f of y is less than or equal to some constant times x minus y. Okay, so this should happen for all x and y. So therefore, you say that f is Lipschitz if there exists a constant c greater than 0 such that for any x, y, this happens. If you look at here, you see this is a fixed number because r is fixed, capital T is fixed, therefore it is a fixed number that you can match with your c here. And since everybody is positive, therefore you don't put the modulus there. So you see that these conditions are precisely Lipschitz condition. Okay, in fact, since you are not putting modulus, so more precisely called one-sided Lipschitz condition. So that's what is the theorem all about. And R is the prevailing interest rate. And remember, both these options have the same period. That is very important. Okay. How to prove this theorem? Let us see. Let us first consider the lower bound for the call option, that is this part, and try to prove this. As you know, the idea is the same because we are working with no arbitrage condition. Therefore, the idea is to assume the contrary. The contrary is that this quantity is negative. That means CE K1 is less than CE K2, right? Then what happens? We will have to construct a arbitrage portfolio using this condition. For that, we will make the following trading strategy. The trading strategy goes like this: construct a portfolio of pi naught in the following way. Write the K2 strike call option and then buy the K1 call option. It means you sell the K2 strike call option and buy the K1 strike call option. So by selling K2 strike call option, what you get is the premium for it, which is denoted by CE of K2. And when you buy the K1 strike call option, then you will have to pay CE of K1, right? So you got this money and you paid this money. Therefore, what you have in hand is the difference between them, that is CE K2 minus CE K1. since you have assumed that CEK1 is less than CEK2, so this will be positive. Therefore, put that money into some risk-free interest rate investment. For instance, you can simply put it in your savings bank account. And now let us see how this portfolio will perform till capital T and what is the payoff at the time of expiration of these call options. Before that, you can clearly see that the value of pi naught at 0 is equal to 0 because you got this money and then you put it in the risk-free investment. Therefore, they get cancelled as usual, whatever we did so far, the same idea. You can show that the value of the portfolio at time t equal to 0 is 0. And now let us see how the portfolio will be exited at capital T and what is the payoff after exiting. At t equal to capital T, we have to close the risk-free investment, and then you have the following situations. When K2 is less than ST, that is the strike price of the second call option is less than the current market price of the stock in the spot market, then you see that your counterpart who bought your K2 strike will come to exercise the option, right? You remember K2 strike was written by you. So the counterpart of it, who is the buyer of it from you, will try to exercise the call option if your strike price is cheaper than the current market price, because he has the obligation to buy the stock, right? So he is getting it from you for cheaper price. Therefore, he will try to come and exercise the option. So what you have to do is you have to supply the stock to him and get the money K2, right? So before doing that, what you do is you exercise your long call option. So remember, if you have to exercise the long call option, you will be paying K1 rupees and getting the stock, right? And for this, you have to supply the stock. So you will get the stock from your long position and supply it to your short position. That's what you are doing here. Exercise the long call option, that is your K1 strike, and obtain the stock by paying K1. Because it's a call option, so you will be paying K1 rupees and buying the stock from your writer as far as K1 strike is concerned. So now you got the stock in hand that you will come to your K2 buyer. In K2, you are a writer and somebody else is a buyer. You will give that stock to K2 strike buyer and sell that stock and get the money K2 for, right? Now let us see what is the value of pi naught at t is equal to capital T. You have, see, this money will come to you with continuous compounding interest. Therefore, it is going to have this value e power or capital T, right? Plus something will come from your option trading. Okay, let us denote it by X naught. Now, what is that X naught? X naught is nothing but, see, you have paid K1 rupees and got a stock, came to K2 buyer and gave that stock and got K2. Therefore, you have K2 minus K1. You sold and got K2. You paid and bought the stock for K1, right? So therefore, the net amount that you will be having in hand is K2 minus K1. That happens when your counterpart buyer in K2 strike comes to exercise the K2 strike call option. When that person will exercise, when K2 is less than ST. Otherwise, you simply don't do anything because you already got a positive return from your portfolio. Therefore, just to prove that it is an arbitrage portfolio, you simply don't need to do anything. So K2 is greater than or equal to ST. So you can see that since K2 is greater than or equal to K1 by our hypothesis, x naught is greater than or equal to 0. So this is strictly greater than 0 and x naught is greater than or equal to 0. So together you have this entire thing to be strictly greater than 0. Okay? So that shows that you have created a arbitrage portfolio. Why it is so? Because this is strictly positive. That is why you are able to create this arbitrage portfolio. That is becoming strictly greater than 0 because of your wrong assumption here. Okay, that shows that this assumption is not possible. That implies CEK1 should be greater than or equal to CEK2, and that is nothing but CEK1 minus CEK2, right, is actually positive, right? That is what we want to show here as a lower bound. So that is proved now. Next, let us take up the lower bound for put option price. Again, assume the contrary, that the price of the put option with strike K2 is less than the price of the put option for strike K1. In this case, we make the following trades. First, you write the K1 strike put option. Thereby, you will get the price PE of K1, and simultaneously you buy K2 strike put option. Thereby you will be paying the premium PE of K2, right? So therefore the difference PE of K1 minus PE of K2 is what is remaining with you, and by our assumption it's a positive number. You invest it in a risk-free interest rate instrument, and you will see that the portfolio which is built by these trades will lead to the value at t equal to 0 as 0. We can check this, and at t equal to capital T, the value of the portfolio will be as follows. Your risk-free investment would have grown with an continuous compounding interest rate of R. Therefore, it will be PE K1 minus PE of K2 into e power RT plus whatever you get from your options, which we will represent as X naught. And what is this X naught? You can see that if the strike price K1 is greater than ST, that is the stock price at the time T equal to capital T, then the buyer of your K1 strike which you shorted will come to exercise the K1 strike option, and therefore he will give you one stock and get rupees K1. Right? So therefore it is minus K1, and you also bought a K2 strike. So what you do, you go to K2, strike writer, give that stock and get the money K2. So this is what happens. Otherwise, you simply leave all these stocks as it is, and thereby you will get a 0 payoff from the two options if K1 is less than or equal to ST. Now, since K2 is greater than or equal to K1 by our hypothesis, you can see that X0 is greater than or equal to 0. And by our assumption, we see that this is strictly greater than 0. Therefore, altogether you can see that this is greater than 0, and that leads to a contradiction to our assumption that the market doesn't allow arbitrage opportunities. So this again proves our lower bound for put option. Now let us see how to prove the upper bounds for both call and put options. For this, we will use the put-call parity result. If you recall, the put-call parity result for K1 strike is given by CE of K1 minus PE of K1. That is the price of the call option minus the price of the put option is equal to S0, the current market price of the stock at the spot market, minus K1 into e power minus RT. T. And similarly, the put call parity for K2 strike is given by CE K2 minus PE K2 is equal to S0 minus K2 e power minus R capital T. So let's call this as 1 and this is 2. Now 1 minus 2 gives us CE of K1 minus CE of K2 plus PE of K2 minus PE of K1 is equal to S0 gets cancelled, therefore K2 minus K1 e power minus RT. Now you see that both these terms are positive. From the lower bound you can see that both these are positive and their sum is equal to this term. Therefore, each one will be less than or equal to this, right? So that is what your upper bound say, that each of this quantity is less than or equal to the right hand side. Okay, so therefore the upper bound is proved very easily using put call parity result. So this completes the proof of this theorem. Next, let us prove another important property of the option prices as a function of the strike price, that is the convexity property. This theorem says that the option prices, both call option and put option prices for European option, are convex functions with respect to the strike prices. That's what the theorem says. If you recall, any function is said to be convex if this inequality is satisfied for any alpha lying between 0 and 1, right? Let us try to prove this theorem. Let us first take the call option case. We prove again as usual using the no arbitrage assumption. Of course, this theorem holds under the assumption that the market obeys the no arbitrage principle. So let us assume the contrary. CE of K is strictly greater than alpha CE of K1 plus 1 minus alpha CE of K2, where this quantity is just for the notational convenience. We will take this quantity as K. Now we have to construct a portfolio. So how we are going to construct? First, write a K strike call option. Remember, K is this number. Okay, so it's just a convex combination of K1 and K2. Write the K strike call option. Okay, so when you write the K strike call option, you get the premium CE of K, right, by alpha units of K1 strike call option. So since you are buying, you will be paying alpha times CE of K1. Okay, so you just assume that such trades are possible. Also, buy 1 minus K units of K2 strike call option. That in that also you will be paying 1 minus alpha into CE of K2. So therefore, you got this money and you paid this money. So the difference between them has to be invested in a risk-free interest rate instrument, and that is a positive number because of our assumption. Okay, so this is the trade that you are making in order to build a portfolio, which we will denote by pi naught, and you can easily see that the value of pi naught at the time t is equal to 0 is 0. At time t equal to capital T, we have to make the following trades in order to close down the portfolio pi naught. As usual, you will be accumulating the invested amount into e power RT from your risk-free investment. So therefore, your value of pi naught at capital T will basically have this money CE of K minus alpha times CE of K1 plus 1 minus alpha times CE of K2 plus you have some money coming from your other options trades. Let us see what they are. If you recall, you have short a K strike call option, right? Therefore, your X naught will be 0 if your strike price K is greater than or equal to ST. Recall, you have written a call option with strike K. If K is greater than ST, then your corresponding holder will never prefer to exercise that option. Therefore, the option will expire without exercising. And so you can take X naught to be therefore 0. If not, that is, if K is strictly less than ST, then the corresponding K call option writer will come to exercise the option. And since he has right to buy the stock, you have to supply the stock, right? So let us see how you are going to supply the stock. You obtain 1 unit of the stock in the following manner. If K1 is less than ST. See, if you recall, you have gone long in both K1 strike call option as well as K2 strike call option with units alpha and 1 minus alpha respectively, right? If you recall, that is what you have made the trade with K1 and K2 call options. Therefore, you will prefer to exercise the K1 strike call option if K1 is less than ST, right? So if K1 is less than ST, you exercise the K1 strike call option and thereby you will have alpha units of this stock. If not, then you simply go to the spot market and buy that alpha unit. Okay, and thereby you are accumulating alpha units of the share in that stock, right? So what you will do here, you will spend K1 and accumulate alpha times the stock. Therefore, alpha K1 you will be spending if K1 is less than ST. And the same idea you will follow for K2 also. And you will, by that, you will be accumulating 1 minus alpha units of the share. So you add together, you will get 1 unit, and that you can go to supply to your K strike call option holder. So that is the idea. So from K1 strike, you will be spending alpha times K1 if K1 is less than ST, and 1 minus alpha times K2 you will be spending if the other one is also true. K2 is less than ST, right? And similarly, if K1 is less than ST, but K2 is greater than or equal to ST, what you will do is you will be exercising K1 call option. Therefore, you will be spending alpha times K1, but you will not exercise the K2 call option because that is not profitable to you. So you will go to the spot market and buy 1 minus alpha units of the stock from the spot market rate. Therefore, it is 1 minus alpha times ST will come. Similarly, if K1 is greater than or equal to ST, but K2 is less than ST, what happens? The K1 strike call option is not favorable to you. Therefore, you will go to the spot market and buy alpha times the stock. Whereas the K2 strike is now favorable to you, therefore you would have exercised your K2 call option and thereby paid 1 minus alpha times K2 in this case. And finally, what is the case? The final case is that if both K1 strike is not favorable to you, as well as K2 strike is not also favorable to you, then both these you would have gone to the spot market and bought the stock. That is 1 unit of the stock from the spot market you would have bought, right? So this is all you would have done in the case of K less than ST, right? If K is less than ST, your K call put option in which you have a short position, the corresponding writer will demand one stock from you by paying K rupees to you. Therefore, you have to somehow arrange that one stock to that person. So how are you arranging that one stock? That you are doing this strategy and arranging one stock to that person and getting the money K from you. So this is going from your pocket, therefore it's minus, and you are getting K from your counterpart in the K strike. Okay, therefore K minus this money is what you have got as the payoff from the X naught if K is less than ST. Now we have to prove that X naught is greater than or equal to 0. How are we going to prove this? Let us see. Let us see case by case. Case 1, let us take, which corresponds to K1 is less than ST as well as K2 is less than ST. That is this part. In this case, you have alpha K1 plus 1 minus alpha K2. If you recall, that is precisely what we have defined as K. You can see here how we have defined our K is precisely alpha times K1 plus 1 minus alpha times K2 is what we have taken as K, and therefore your K minus K is what is coming here. You will have this is equal to K minus alpha times K1 plus 1 minus alpha times K2, and that is K minus K, and that is actually equal to 0. Let's take case 2, that is when K1 is less than ST and K2 is greater than or equal to ST. In this case, X naught is given by K minus alpha K1 plus 1 minus alpha ST you have, right? Now again, what is K? K is nothing but alpha K1 plus 1 minus alpha K2 minus this term. So K1 alpha gets cancelled and you have 1 minus alpha into K2 minus ST. But in this case, we have K2 is greater than ST. Therefore, this is greater than or equal to 0. So in the case 2 also, we have seen that X naught is greater than or equal to 0. Similarly, you can show that X naught is greater than or equal to 0 in the third case and as well as in the fourth case. And that will cover our aim that X naught is greater than or equal to 0 in the case when K is less than ST. When K is greater than or equal to ST, anyway X naught is equal to 0. Therefore, there is nothing to prove. So this shows that in any case, whatever may be ST at the expiration T equal to capital T, your X naught is going to be greater than or equal to 0. And you can see from your basic assumption that this part is strictly greater than 0. So together you achieved that your portfolio value at T equal to capital T is strictly greater than 0, and that is a contradiction. So this contradiction proves the convexity property of the call option price in the case of European option. Finally, to complete the proof of the convexity property, we have to still prove the inequality for put option. So one can prove the inequality by constructing an arbitrage portfolio as we have done for the call option case. There's also another way of proving this inequality, which is relatively simpler, that is using the put call parity result. Let me give you the proof using put call parity result and leave the other method, that is constructing the arbitrage portfolio, as an exercise. Recall, from the put call parity result, we have CE of K. Remember, K is the convex combination of K1 and K2. We will be considering the put call parity relation for K strike options. So it's call option minus the premium of the put option is equal to S naught minus K e power minus RT. So this is what our put call parity relation says. Now this implies PE of K can be written as CE of K minus S naught plus K e power RT. Now for this, you use the convexity property of the call option price, which we have already proved, and that gives us alpha times CE of K1 plus 1 minus alpha CE of K2 minus S naught plus K e power RT. That is what we get. And from here, you can just group all the terms. So I just write it here. This is equal to, you see this part you keep as it is, minus S naught plus K you expand, alpha K1 plus 1 minus alpha K2 e power RT. Now alpha terms all you group together and 1 minus alpha terms all you group together, you will get alpha times CE K1 plus K1 e power RT. Now you have one full S naught that you can write as alpha times S naught plus 1 minus alpha times S naught, right? So one term, that is alpha times S naught, you put here, and similarly 1 minus alpha times S naught you put in the other group, 1 minus alpha. Now you group all the 1 minus alpha terms, CE of K2 plus here you have plus K2 e power RT and minus 1 minus, see you have alpha S naught here and therefore 1 minus alpha S naught you group here, and that is precisely your alpha PE K1 plus 1 minus alpha PE K2. So this is precisely what we want to show as the convex property of the put call price. So we obtained this, and this completes the proof for convexity property. By this, we have completed two important properties of the European option prices, that is the one-sided Lipschitz property and the convex property of the price of European options. The same results also hold for American options. We just take them here and leave the proof as exercise